Today's lesson, section 3.4a, we're talking about real zeros of polynomials. And specifically, we're going to talk about Descartes' rule of signs, which is a tool that we use along with the rational zero theorem to help us identify what zeros are going to happen for any given polynomial. Okay, so this is just a tool. It's not something that's going to tell you exactly what the answer is, but it kind of helps. Okay, so here this is a process that shows the number of positive, negative, and imaginary solutions that are possible for any given polynomial. So let P be a polynomial with real coefficients. So the first thing you need to do is the number of positive real zeros of P of x is either equal to the number of the variations in sign in P of x, or is less than that by an even whole number. Okay. The number of negative real zeros of P of x is either equal to the number of variations in sign in P of negative x, or is less than that by an even whole number. So, now, that sounds really ridiculous and hard. Okay, so I'm going to break it down. So, basically, what they're trying to tell you with Descartes' rule of signs is you're looking at the changes in signs for the positive function and for the negative function. So when I look at the function that I'm given right now, okay, and I want to look from the largest degree term all the way down to the constant, and I go one by one. So it doesn't matter if there's a missing one or anything. So I don't need to fill in a 0x squared or anything if there's something missing. So I'm going to start with this first one. So this one's positive, this one's negative. This one's positive, this one's negative, this one's positive, right? Okay. Now, I want to count the number of changes from left to right as I move from the highest degree to the lowest degree. So from x to the fourth is positive to negative 9x cubed. There you changed from a positive to a negative, so that's one change. Okay? So I'm just going to keep track. From negative 9x cubed to 28x squared, I'm changing again from negative to positive, so there's another one. And then from 28x squared to negative 36x, I'm changing again, so there's another change. So I've got 3 so far. And then here, I go from negative 36x to positive 16, so I went from negative to positive. There's another change. So notice, it doesn't matter how it changes, it just matters that it changes sign, okay, from one to the other. So I had 4 changes in sign. Now what that's telling me, and I usually make a chart with this, okay, and so this first column that I'm going to make is the highest possible zeros for these two. Let me do that in a different color. For the positives and the negatives. Okay? So here, because the highest number was a 4, that's what I'm going to put in. Okay? So that tells me that because of all the changes in signs, the most possible rational zeros, or real zeros I can get, are 4. Okay? Now I want to do the same thing for the negative. So to do that, because this is a positive x, I'm going to plug in a negative x and change the sign. So that means every time I see an x, I plug in a negative x. Okay, and then I want to see what that does. So here, for any even power, it cancels out the negative because it makes it positive. For the odds, it changes the sign because the odds don't get rid of anything. Okay, so noticing this, as I move from one term to the next, I have 0 changes because they're all positive. So that means that I have no possible negative real solutions. Okay? So if I was trying to find all the real zeros of this polynomial, that would help me a lot because remember we make that list of rational zeros. Okay? And so if you get a big list and it says that there are no negative answers, that means you can cross out all the negative answers. So you just cut your list from, like, let's say if you had 20, because there's 10 ratio or rational numbers with plus or minuses, so that makes 20 possibilities. You just cut all your solutions or the list that you have to look at in half. So that's why that's important, or a nice tool. So sometimes it can be very helpful. Now, the next thing to talk about is this imaginary one. Okay? So here, let's put this in a different color. Now, you're probably wondering, what do I put for the imaginaries? Because it's said in Descartes' real science that it tells you positive and negative real zeros and imaginary solutions. Okay? So here, the first one, it's going to be 0, because each column adds up to the highest degree. So if you go back, the highest degree is 4. So each column should add up to 4, no matter what. We already had 4 with the positive real zeros, so that means that imaginaries are not. Okay? Now, it also said in Descartes' real science that each of the numbers, so it's the least equal to the number of variations, okay, in sign for p of x, okay, which we got for 4, or is the less than that by an even whole number. So that means that it could be less than this 4, because I'm just saying possible. I'm not saying for sure there's 4. I'm saying possibilities. So the highest amount it could be is 4, but it could be less. But now I go down by a negative or an even whole number. So that means I go down by 2 every time. So that means another possibility could be I get just 2 real positive zeros. Okay? I still can't have any negatives because that number can't go down any further. 0 is the smallest you could be. You can't have negative solutions. Okay? But now that means that, remember, my columns have to add up to 4. So that means I could have 2 complex or imaginary solutions. Now, think about this. The reason why it's a whole even number that it needs to go up or down by, or really down by, is that if you go back to the conjugate root theorem for I, if I have any root of a plus bi, and it's a solution, then that also means that the conjugate is also a solution. So imaginary solutions come in pairs. So that's the reason why this has to go up, or this has to go up by 2, and these have to go down by 2, because of that fact. Because you can't have one imaginary solution. It's not possible. You have to have an even number. So now another possibility, this 2 can go down further. Okay, it could be less because you can get 0. 0 is still less than 0 for the negatives, so can't go any further there. But then the 2 can go up to 4 because I need my column to add up to 4. So now I just created a table with all the possibilities for my my real zeros. Okay, just based on what I did with Descartes' real science. Now, it's hard to start with this. Okay, I need to do several examples to show you kind of what we're looking for, and because there's different possibilities. Okay, it's not always what it's going to look like. So sometimes Descartes' real science helpful like this, and sometimes it's not. That's kind of the drawback to doing Descartes' real science, because if you spend time on it and it doesn't really give you any great information, then it kind of seems like it's a waste. But so it's not something you have to do. Like when you're solving, it's just a tool that you can use if you need a little help. Okay? So let's go on to the next one. So here I have 6x to the 5th plus x cubed minus 9x squared minus 4x. Okay, and like I said before, you don't need to fill in the gaps. So like I don't have an x to the 4th and I don't have a constant. It doesn't matter for Descartes' rule signs. Okay, so you just worry about the signs that you have. So I get a positive here, negative, and a negative. Okay, so when I look at the changes of signs, there's 0. It goes from positive to positive, and then it goes positive to negative, so there's 1. And then it goes negative to negative, so I've only got one solution here, okay? Or one possibility for my positives. So let's make our table. So there's 1, okay? Now let's do the negative. So if I plug in negative x, okay, that gives me negative 6x to the 5th minus x to the 3rd. Looks like minus 9x squared and a positive 4x. Okay, so here I got minus, 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 plus. So from there, none. From there, none. From there, 1. So I could have one possible negative solution here. And so then remember, the top part needs to add up to, so now like I said, you need all your columns to equal the highest degree, so it's 5. Now, let's talk about this. So then the imaginary solutions have to be an even number, right? Because of the conjugate root theorem. But here, for you to complete this, you get 3 to make that true, and then, but that doesn't jive with the conjugate root theorem. So, think about your solutions up here. Look at your polynomial. I believe we can figure out one of the solutions right now, which is where x is equal to 0, because I don't have a constant term at the end, so each term has a value of x, so you could factor that out. So really, I don't need to make this equal to 5. It needs to be 4 because this is neither positive nor negative nor imaginary, so it doesn't really count in my list. Okay? So now, if you make it 4, then you get a 2. Okay? And so then that makes a little bit more sense with what we're doing here. Okay? Now also, if you're trying to look at the other possibilities, looking at 1, you can't go down by an even number because it's like just 1. So it can't go down by 2 because it would be negative 1. Same thing for the negative 1, or negative is real zeros. You have a possibility of 1 at most, so it can't go down by 2. And now another thing that kids kind of forget about is that just because you have 2 together, you can't take 1 from both and give it to the negatives. That actually doesn't work. So you have to only take 2 from the positive to move it down, or just 2 from the negative. You can take 2 from both because it's an even amount for both, but you can't do it for one of each. Okay? So this is my only possibility is 1, 1, 2. Now for this one, for this like as a tool to solve this one, other than the 0, it's not super helpful. All it really tells you is that you're going to have 1 positive, you're going to have 1 negative, and then 2 of them are going to be imaginary or complex. Okay? So it doesn't really shorten your list. It just tells you that there's going to be an answer, so that's kind of helpful in a sense, but it's not super helpful. Let's try another one. So here, j of x, you have 4x cubed minus 19x squared plus 19x plus 6. So changes in sign, so there's 1, there's 2, there's none. So 2 is my only value there. So I get 2 for the first one. Then let's plug in negative x. Okay, so it gives me negative 4x cubed minus 19x squared minus 19x plus 6. So here, none, none, and there's 1. Okay? So I have 1 change for my negative. Okay? Here, the highest degree is a 3, so my imaginaries would need to be 0 for this first possibility. And then now, because the 2 is on the positive, I can take 2 away from that and make it 0. The negatives can't go down because it's can't take a 2 from that to make it something less, because it would be negative possibilities. And then that means that 2 would have to be the imaginary. But this one, there's only 2 possibilities. So the nice thing about this one is that it gives you a little bit more focus, because you know that there's a negative solution in here, so then you should just try all the negative solutions. It's not ruling out the positives, but you should start with the negatives almost. Okay? And then letter D, there's 1 change, there's 2 changes, there's no changes there. Okay? So there's 2 possible positive real zeros for this one. That's the highest possibility. Let's do the negatives. No, oops. Forgot my parentheses. Okay. So that negative cancels out. That one changes it to positive 4x cubed, negative 8x plus 3. Okay, so no change, 1 change, 2 changes. So here you get 2. Now this one's going to have lots of possibilities. Okay, so I could take 2 from the positive. That means that there's 2 imaginary. Or, let's go back to the 2, 2, 0. Okay, you could also, instead of taking 2 from the positive, you could take 2 from the negative. So that's also a possibility. But you could also take 2 from both. That means there's 4 possible imaginary numbers. Okay? So here you have 4 possibilities. Now this one really doesn't help anyone ever. Okay? This type of table. There's 4 possible scenarios, but it doesn't tell you, because you don't know what to look for first. So this is why the Descartes' rule sign sometimes is not helpful, because right there I wouldn't know exactly where I want to go, so it's still going to be a guess and check game for the rational zero theorem. Okay? But this is kind of what Descartes' rule sign is talking about. Sometimes it's helpful, sometimes it's not. Okay? Use it as you wish when you're solving for polynomials. Okay? Have fun.